Hopefully it gets started. The recording is starting. Can I start that second way, or do you? Thank you. All right, so we're recording. All right, so this is the first call since I guess last time we were live. So we go back to our typical agenda. We have a pretty packed agenda. We do updates, and then we have tweet talks. So we got Bo Young from IBM who's going to give us an update on App Autoscaler. We have Ashit Jain from SAP who's going to give us an update on the Service Fabric. And then we have Dimitri, hopefully at his desk. He's actually maybe a few feet away from us here. And he's going to do a live presentation of the BOSH CPI for Kube. Should be fun. You know, I've been doing it in Europe, but we're going to do it now, and it's going to be recorded. So let's get started. I think usually we give Chip and Swarna a chance to give us an update on the foundation. There's a big summit coming up in Europe, so maybe we can get some idea of what's going on there. Swarna, do you want to?
Yeah, Swarna's typing, so she asked me to do it. So, yeah, so a couple of major topics. Of course, there is the summit coming up in Basel. A reminder that June 1st is the deadline for the CFP, so you've got about half a month left. Also, thanks for everybody that voted for the track chairs. We really got a great response to the voting process, and we'll be announcing who the winners are shortly. We kind of have to collate the results and make sure that the same person isn't in multiple tracks. So that's all going really well. And again, get your talk proposals in. The other thing, obviously, you're going to show, or we're going to see the CPI for Kubernetes, which is awesome. But there's also a lot of other amazing projects that are happening both inside our project teams as well as kind of outside in the broader CF community. Reminder that we've been having a bi-weekly call to try to get through updates on all these activities every other Wednesday. It's happening next Wednesday. Go to the mailing list to catch up on details. We're going to switch to Zoom as well for that effort or for that regular meeting. And also, you could go back to the North American event from Boston. And if you take a look at the cloudfoundry.org site, you can get to all of the videos, cool pictures. So every talk was recorded, and there's binge watching pleasure if you're interested for hours. So I think those are the highlights.
I'm also adding the links to the videos and pictures onto the CAB call meeting notes document.
Awesome. Thanks, Marty. Cool. So that's it.
Yeah, great. You can hear us, right, Chip?
Yes.
Okay. I guess nothing else to add here. We'll switch to the PMCs. We usually start with the, I guess, runtime PMC, and we are viewing here. Anything to highlight?
So we had our regular bi-weekly meeting yesterday, so you can go check out the notes to the meeting, the PMC notes repo. Some of the highlights, we sort of a housekeeping thing, but I had forgotten to put out a call for the CLI project lead. I was out for jury duty. By the wayside. Jay went back to work on an internal project at Pivotal. So Abby Chow has been serving as an interim project lead, but the nomination period until next week. Also, the project Irene was proposed for incubation within the application runtime PMC, and that was accepted for incubation. and Jules was proposed as the project lead for that, and that was also approved.
Thank you. I think they are saying that it's
Yeah, that mic is just not working. We're on probably the TV.
I see. So we have to shout at it, I guess.
Yeah.
Okay.
All right.
So just as a quick repeat, hopefully you can hear me. Abby Chow is proposed for project lead for the CLI. Nominations for that are open until next week. And we accepted Project Irene and Jules for incubation into the runtime PDBs.
Thank you. Eric, do you want to add anything in terms of Diego, maybe updates on that?
Yeah, let's see.
Yeah. Sorry.
I think more broadly, I know Cappy's been working on a bunch of interesting initiatives around finishing support for server-side app manifests and continuing on their zero downtime app effort. So they haven't had anything internal for Diego to do yet in terms of instance management, but we're keeping in touch with them.
Okay, very good. Thank you, Eric. Any questions so far? Let's see. No.
Other highlights kind of include starting to plan for a new rootfs, CF Linux FS3, which will be based on Bionic Beaver. Although the build packs team will be managing that, and Scott Sissel and Stephen Levine can tell you all about that. And asking the teams within the runtime PMC to start taking a look at the Xenial stem cell and making sure we're compatible with that. And that one is based on Xenial 1604.
Excellent. Thank you. Planning with Dimitri yesterday. Not quite there yet, but it will be soon.
Okay.
But you can ask him. He's on his way.
We'll be waiting.
All right, cool. So let's do the extensions, because I think Dimitri is on his way, and I don't see Danny. Is Danny on the call? You want to do an update on BOSH? No. Okay. So for extensions, I guess the two main highlights are that we did a vote, and we have accepted the two projects that were proposed. This, as you might have seen from my last email with respect to extensions, was the Microsoft SQL broker. So this is a broker for Microsoft SQL Server. And this is something that I think Pivotal has worked on, but in conjunction with Microsoft, and Microsoft will be taking over that and supporting it. So if you're a user or fan of Microsoft SQL Server, then you should take a look at that. It's going to move into the foundation. So Zach Brown from Pivotal has led that effort, but I think Microsoft will take it over. The second one is very important in terms of the scope of it. This is an effort by SAP. The team from SAP, Nikolai, is here. And they're always eager to give us an update and talk about it, but basically it's the multi-apps. So this is a way for you to deal with multiple apps and how they connect together and so on. There's a whole set of presentation that they did before that at Summit and also in the CAP call. I'd encourage you to take a look at that. We'll transition that to the incubation, and then hopefully Nikolai and the team will discuss it, and then we'll give them an opportunity in a future CAP to come and propose it. So these were the two projects. They are worth a highlight. There's tons more going on in extensions, but we can tell you that next time. Definitely pay attention to Stephen Levine. He has tons of things going on in extensions.
Thank you, Max, for arranging this.
Say that again?
Thank you, Max, for arranging this.
Sure, no problem. We are happy to have you.
Okay.
Hopefully, you get a chance to present soon again on this. So I don't know if anybody have any question for us, extensions or any other projects. There are few of the leads out here. So if you have questions. No, we're gonna get to the main event. All right, cool. Since Dimitri is gonna be doing the presentation for the BOSH Kube CPI, I don't see Danny here. He usually attends, but I told him that we would start the BOSH stuff at 1:30, so maybe that's what's going on. So they'll give us an update on BOSH. You already heard about the xenial stem cell, but they might have other updates. So let's switch over to the two presentations. We'll start first with Bo. Bo is a member of the team. I guess, Jules, you want to introduce Bo? I see that you're here.
I'm sure Bo can introduce himself.
All right. Okay. Cool. So Bo is going to give us an update on the app autoscaler, and if you want to go ahead and maybe take over, you can share your screen if you want to show us something.
Yeah, I just shared. Can you see the screen? Okay.
Yep. So go ahead, Bo.
Okay. So as Julian said, so let me introduce myself first. So I'm one of the initiator of the App Autoscaler project and the core contributor of this project. I'm from IBM. So let me first introduce what is App Autoscaler, right? So this is actually a Cloud Foundry service, which enables you to automatically adjust the number of the Cloud Foundry application instances based on the policy you defined. So by using this App Autoscaler, you can maintain the availability and maintain the policy service of your application. And okay, and a little bit of history of this project, right? So actually, this project has been there for 2 years. We started this project in the middle of 2016, and we have core contributors from IBM US, IBM China, SAP India, and Fujitsu in Australia. So this project actually is based on code donation from IBM Cloud Autoscaler service, and we got some of the code. Firstly, open sourced. That part is actually for the V1. It's based on Java, and it's a pretty monolithic implementation. Well, we redesigned with the microservice architecture and then rewrite that service in Go language and Node.js. So there are several adoptions for this App Autoscaler service. So actually, from October last year, SAP Cloud has deployed that on production. So it has been running there for quite a long time, and it's demonstrated to be stable. So which gave us quite a few confidence that people can go and use it. And from IBM side, actually, we're including this App Autoscaler as one of the extension package of IBM Cloud Private. And now we are, adding this service as part of, IBM Cloud Foundry Enterprise Edition, which is a public isolated offering of the Cloud Foundry in IBM Cloud. And eventually, we replace the existing IBM Cloud Autoscaler service, which is a proprietary implementation with this open source edition. It will happen sometime end of this year or maybe early that year for public cloud as well. The other adoption is SUSE is now including this service as part of this SUSE Cloud Foundry distribution. And we also have talked to Pivotal Web Service because Pivotal Web Service also have Autoscaler service there. We are looking at the possibility to firstly open source Pivotal implementation and then convert these two projects into one, so that we can have one single Autoscaler service in the community. A little bit stuff on the components. I don't want to dive deep into the components of the autoscaler, but I want to bring up here is that actually quite a few of the components are common enough. So if we, it's pretty easy to extend this autoscaler to other domains besides Cloud Foundry application. Like, okay, we can customize the metric collector and the scaling engine so that we can auto-scale Cloud Foundry platform components. We can also do that for scale out Kubernetes. Several key features, right? Now we support two types of scaling. One is we call it dynamic scaling, which is based on performance metrics. Now we have a built-in metric support for memory use, the memory usage, throughput, and response time. So this built-in metric support will apply to all the Cloud Foundry applications. There is no code injection in your application. We just aggregate these metrics from log aggregator, so you get it when you push your application, no matter what runtime you're using right now. The other type of scaling, and we call it schedule scaling. Basically, you can define a time slot for your scheduling. For example, if you want to scale every Monday morning at 9 o'clock to 11 o'clock with a number of instances, then we can do it. For the schedule scaling, we support both a recurring schedule, something like, okay, every week, every Monday in every week, right? And also every first day of that month, something like that. You can specify a specific schedule as well. That is not recurring. Now we make the service broker to be fully compliant with Open Service Broker specification. And the service also have APIs to manage the policies. Also, you can use the APIs to query metrics and the scaling histories for that. There is a corresponding, command line interface now already in the community, Cloud Foundry plugin, CLI plugin repository, so you can freely to download and use that. So before I go into the next few slides, I'd like to give you a short demonstration because it may take time to scale out, scale in application. So I just record that demo. Let's do that. I'm not going to show how to deploy that. It's a BOSH release. So basically, once you deploy Cloud Foundry, you can deploy, using the BOSH, deploy the app autoscaler service, right? In this demonstration, I'm using the BOSH Lite. Firstly, sorry.
You have 4 minutes.
Okay, no problem. Let's see what are the deployments. We have a CF deployment, right? And we have a app autoscaler deployment there. So before using that, you have to register this service, right? Using the CF CLI, you create the service broker. And then you enable the service broker access. Now you can see the autoscaler service in the CF marketplace. Then let's install the Cloud Foundry command line plugin for autoscaler. Yeah, it is here right now. Right? And let's do the demonstration of how to scale your application. Firstly, you have to bind the autoscaler, create and bind autoscaler service to your application. Let's push sample app here. And it's running right now. And let's create the service. And you can bind the service with a policy. And let's take a little bit look at the policy itself. So basically, the policy is I want to scale the application based on throughput, right? Once it's less than 3, and I need to scale in with 1 instance. And if it is more than 5, and scale out with 1 instance. So it's a pretty simple one. Let's see how it scales in and scale out. right? And this window actually shows the benchmark 2. We are using AB benchmark 2 to drive load. And there are several other windows here. This one is show the metrics of your application we retrieved, and also the scaling history. And we also show the app stats. Let's see what is going on. Let's drive the load first. And you may need to wait some time to get the metrics retrieved. And you can see there is inless 0 for your application. There is 4 requests per second. And it goes to 10, right? And it should be an evaluation that the application needs to scale out, but it may take some time. You can see there is a scaling history here. The instance number from 1 to 2, right? And you have 2 instances from the app stat. And then I queued the benchmark 2 then to say how it is scaling. And there is throughput becomes 0 because I queued the the load. Actually, there is no load right now.
So you're gonna wait for it to scale down, right?
Yeah, it's a scale down to 1 instance.
I guess we're watching the bottom right.
You can watch in this one and this one, the scaling history and also the app stats. Okay, so there is an additional scaling history. The instance number changed from 2 to 1. And then if you get the stats of the application, there is only 1 instance running. So this is a very simple demo. And what is, what is coming in the near future? So one of the things we got from the customer that they want customer metric support. So we are going to support that. And we are now working on the dashboard. It's still internal development. We are going to open source that dashboard as well so that you can see the service dashboard GUI. You can configure policies since, get some of the scaling histories there. Here, I show some of the screenshots here. So the policy configuration, the metrics dashboard, and also the scaling history. There are other things like we are going to migrate to log aggregator V2 API, or we use log cache because it provides nice features for metrics query. We haven't decided yet which way to go, but we will do that, right? No matter it's V2 API or log cache, given that the log aggregator V1 API is going to deprecate it by the end of this year. The other major things we want to do is a performance scalability improvement. Our goal is to support 10,000 applications. I guess that given that there is a small percentage of the application using autoscaler, so this basically means that if we support 10K applications, it can serve the largest deployment right now. And the other thing we are considering is to extend this implementation to autoscale Kubernetes as well. So this is what I have for this meeting today.
Yeah, excellent. Thank you both. Hopefully you have a slide also with links to, I guess, the video.
Yep. Yeah, there are some of the links for
that would be great.
3 projects there. Okay.
Yeah, right. Let's see if we have at least one question. We could probably take one question. Remember, you're on mute, so you probably have to unmute yourself. Otherwise, Bo, if you can just start unsharing, so that way we can get Ashish to start sharing.
Yep, I stopped.
Yeah, thank you very much. Well, thank you, Bo. This is great. I mean, I can see the progress, and thanks for the overview in a very short amount of time. I appreciate that. Thanks.
No problem. Thank you.
Yes, man. All right. So, Ashish.
Yeah, hi, Dr. Max. Yeah.
And you also share your screen. I can also see Dimitri at his desk, so he's gonna be doing the presentation after. So Ashish, if you can give us an update on service fabric.
Yeah, sure. So you can see my screen?
Yeah, we can. Go ahead.
All right, yeah, so thank you, Dr. Max, for giving us opportunity to present this in today's CAB meeting. So since we achieved incubation, this is the first time I think Service Fabric is presenting in the CAB meeting. So I've got a couple of slides here. The first one which talks about since incubation till I would say the Boston Summit, what is that has been done as part of Service Fabric. And in the next slide, we'll talk about what's the roadmap in place. I think these were for a few of the commitments also when we initially proposed for incubation. OSBA compliance was one thing which was, I mean, when we proposed incubation, we were compliant to 2.9 version of OSB API. So now we can say that we are compliant to 2.13 version of OSB API. And this was also a requirement from basically to decouple some of our lifecycle operations from Cloud Foundry, because as we move on, we know there is an increasing adoption of basically the integration between CF and Kubernetes. So as part of this, we decoupled our lifecycle APIs from CF, and now we can say we are a truly OSBA compliant broker. And then moving forward, so Service Fabric also provides some of the extension APIs, so which will be covered as another story, which we'll talk about. Adoption of BOSH 2.0, this was an important story for us and was also a commitment from our side as part of our incubation proposal. The major requirement basically was to make Service Fabric modular and support BOSH 2.0 as far as manifest and ops files and the various constructs which are provided by BOSH 2.0, and also make sure that the backing services basically which are deployed using Service Fabric are also are able to adhere to BOSH 2.0. BOSH 2.0 and then with respect to so there are a lot of things which BOSH 2.0 brings to the plate. XFS file system is a major thing, and then dynamic IP allocation for use cases like sharding, and then of course the adoption of the ops files and other aspects, right? Then another next item is basically schedule update window for service instances. So with respect to this, the idea was that the various instances which are updated. So today, if you know, Service Fabric also has a scheduler component in place, which basically schedules updates as well as backups too. So the idea about this particular story was that to basically spread the schedules across a window of, say, for example, a user-defined window of a week or a few days, or maybe a few hours within a day, so that the end user knows when his instance is going to get updated, and it gives the end user some transparency around their backing services instances. CF-CLI plugin for backup and restore. So today, as you know, Service Fabric also has got extension APIs for backup and restore, and as part of this, plugin was developed and was open sourced as part of this story. Pre-update API. So this again has got many use cases. Before triggering an update for a backing services, the idea is that the users can write some of the scripts or provide some of the constructs using which they can basically do some operations. For example, they may want to maybe modify the manifest or inject some metadata within the newly generated manifest. Yeah. So this is till I would say till the CF Summit Boston. This was what was delivered as far as Service Fabric. Moving to the roadmap. So the roadmap is quite exciting for Service Fabric. So there was so the first item is Service Fabric 2.0. So we also made a presentation on Service Fabric 2.0 during the Boston Summit. Some of the items, for example, integrating the community projects, like say, for example, BBR, bringing BBR or maybe a Shield or some of the other monitoring frameworks, for example, Prometheus, or for example, getting a new provisioner onboarded onto Service Fabric platform. So today we support BOSH-based provisioning and Docker-based provisioning. So for example, to bring it a K-test provisioner, today it is quite a humongous task considering the Service Fabric 1.0 architecture. So the plan is to basically move to a much more modular, pluggable, event-driven architecture where some of these shortcomings can be easily achieved. So that's the plan with respect to Service Fabric 2.0. A presentation is also available, can be looked upon. Service Fabric HA, NZDM, and multi-AZ, right? So today Service Fabric is deployed on a single VM, so it is a single point of failure. So the plan is to basically make it basically highly available and make sure any updates or any there is a very minimal downtime in place when the VMs get updated, and of course support multi-AZ on various EAs. So the work, so there is some work which is ongoing on this, at least on the AWS platform, and we have been doing some tests, and at least we can say that keeping multi-AZ aside, HA and NZDM, I think we can basically achieve at least 2 to 3 seconds of is the time which is required today for a failover. Moving forward, then, and the idea is to basically support it on the various EAs actually. Rate limiting, right? So this is again a very important story. The idea is that today, when Service Fabric talks to BOSH or various components, I would say CF, there is no rate limiting in place. Today, we just send the request and then we wait for the target platform to just respond back. I mean, at times we have seen that we have hit in our tests that we have hit limits for on an ES or on BOSH or even on the cloud controller. So the plan is to basically apply some of the rate limitings within Service Fabric, and moreover, when it comes to some long-running processes, for example, long-running requests, for example, a major version upgrade for a backing services, which may take a lot more time than a regular, probably a stem cell update or maybe a regular code update, right? So that all the various, for example, if you consider a BOSH update, right? So it may end up using all the BOSH workers for for all the BOSH workers can be occupied by, say, suppose 12 simultaneous updates, considering that the BOSH workers are configured to 12, right? So so as to make sure that there is a fair share given to various requests. So that's the idea behind this. Context-based scheduling. So I think I just discussed in the previous slide that we have a schedule updates window in place, but we see some limitations now with that approach, where what happens is it is just a plain time-based scheduling which is in place. So the idea with this story is that we be more deterministic. So today when you send an update, we don't know the target state of the system. And, for example, BOSH. Right, so what's the load on BOSH, or whether there are enough capacity available in BOSH or not. So, yeah. So the idea is to basically be more deterministic and do an optimal utilization of resources. Deployment hooks, another very important story. So the idea is that we provide some of the pre and the post hooks when it comes to the CRUD operations, and then give users capability to have some operations in place. For example, if you want to inject credentials into a manifest, you should be able to do it in a pre-create operation. And then moving forward, the plan is to do some of the performance benchmarking and stabilize the whole Service Fabric platform to an extent. So the performance benchmarking will cover various aspects. It could be basically the interaction with the EAS, or it could be, as I discussed, with Cloud Controller or the BOSH or various components with Service Fabric talks. Yeah. So that's a brief update from my side. If you have any questions, please let me know. Yeah.
All right, thank you, Ashish. Let's see if anybody has a question. If you can unshare your screen.
Sure.
Thank you. So as we are waiting for question, Dimitri, if you want to take over. Any question for Bo or for Ashish as we are setting up for the last talk? No? All right, cool. So we're going to the main event. Dimitri, I guess you have to unshare your screen, Ashish. Yeah, perfect. Yeah. Thank you. All right, DK. So this is a project that we've been working on. I think it's incubating in BOSH. So Dimitri, take it over.
Hey.
We can hear you. And
for those who don't know me, I'm Dimitri, and this thing does not work for some reason now. Where is the present button? Slide, arrange tools. Type that in.
You present.
Present. All right, Zoom, I guess, affects computers in all kinds of ways. So yeah, for those who don't know, I PM BOSH. I also happen to work with Max all the time. So this is the presentation that Max gave first time at KubeCon in Copenhagen a couple of weeks ago, I think. So given that we have about 20 minutes, we'll probably go a little bit faster or maybe skip certain things. But feel free to interrupt at any time, and you know, let's make it as easy interactive as possible. BOSH and Kube. You know, some of you already know that there's been previous attempts and figuring out how to integrate BOSH with Kubernetes. You know, whether it's a good thing, whether it's a bad thing, you know, different approaches and whatnot. So this presentation again explores one of the approaches that we've taken and kind of tries to put a particular framing around you know, what we're right to do. Who's this guy? Well, that's Max. He's orchestrating this meeting. He likes bicycles, and he's slightly going away now. Boom. All right. Slacker here. That's me. I'm on Slack over there. What's Kube? Well, I think hopefully everyone knows what Kube is at this point. It's, you know, according to the GitHub page, production grade container scheduling and management. Different people kind of view it as a different level of platform. Some people use it as a PaaS, even though it's not necessarily designed that way. Some people use it as an IaaS, even though, again, it's not necessarily designed that way. A lot of people view it as just a set of primitives that they can build something on top. That's probably more closely to what people advertise Kube to be. We'll see. What is BOSH? Well, you probably all know already what BOSH is. We use it to deploy a lot of production workloads. It's effectively also an orchestrator. It also provides a, you know, full-blown tool chain for release engineering, deployment, lifecycle management, and as it over here says, small or large scale cloud software. Well, mostly medium-sized, but we definitely have users that go for smaller or larger. All right, Kube operators. Not sure if everyone has heard, but for those who haven't heard, operators is a concept that's been popularized by CoreOS, right? Why do we need it? Right, so CoreOS, the way it describes operators is as following, right? An operator is something that you effectively use to help you manage different kind of stateful applications, maybe more complex stateless applications. Another kind of a quote that CoreOS uses to describe operators is something that, you know, how do we encode some of the human knowledge at operating different software, right? Now, obviously, if the software is pretty easy to operate, you probably don't need any additional stuff like operators or like other processes. You just, you know, maybe use BOSH directly, maybe use CF directly, maybe use Kube directly. But sometimes, especially with the data services, you do need that extra level of help from something. All right, well, some open source examples out there nowadays, etcd operator, Postgres operator. So they respectively manage etcd and Postgres kind of a clusters. I'm not sure what this picture shows. Maybe Max knows what this picture shows.
It's taken from the Prometheus operator. That's basically showing what it does. But you can move on.
Well, my vote is we skip the slide since it's super blue and confusing. All right. All right. So the way we kind of were discussing with Max, what is the kind of an interesting way to position BOSH in regards to Kubernetes? Is there, you know, can someone provide a generic operator, right? And if we do so, well, yes, we can. And if we do so, how useful is it, right? So we don't quite know, right? I think this really goes from you know, lots of experimentation. We could potentially determine if it's something that's useful while operating Kubernetes cluster and using maybe BOSH with it. We'll see. What if we could? All right, let's take a look at what if we could. So it looks like there is some fancy things going on there. So we have any software that we're orchestrating, we have some kind of a generic Kube operator, and then I guess this generic Kube operator is actually creating all kinds of different Kubernetes concepts. I will go into detail on some of them whatnot. But this is how I guess the typical layout would look like if we're talking about the generic Kube operator. Now, if you just replace this generic Kube operator with etcd operator, you know, and replace like service 1 with, you know, etcd node 1, etcd node 2, etcd node 3 and whatnot, right? You suddenly see it being a little bit more specific, right? So the proposition of this presentation is, well, what if BOSH could be this generic Kube operator? And I guess any software that you can deploy would be packaged as BOSH, and, you know, you will, you know, reap the benefits of BOSH that potentially you've learned or maybe learning so far. All right, and I guess that was the slide to kind of sell the main point. But you know, BOSH has certain capabilities in how you install, configure, and update workloads. Right, it's fairly well established tool to manage production workloads. It has its own, you know, benefits. It also has, of course, its own disadvantages. But there is at least an interesting experiment to do, you know, across the community. What if we use BOSH to manage some of the workloads on top of Kube? Now, how do we do it? Well, as most of you will probably know, there is this interesting abstraction that we have in BOSH called CPI. CPI extension point allows you to integrate, well, allows BOSH to integrate rather, with different IaaS, container as a service systems, maybe it's some kind of a bare metal APIs and whatnot, right? So given that BOSH is, the way at least I view BOSH is more of a generic compute orchestrator, a CPI is a natural extension point to, you know, implement at least basic integration with Kubernetes. You know, to get into more details, currently CPIs abstract away images, compute, storage, and networking from the rest of the BOSH, right? Mainly from BOSH director. That, of course, leads for us for a big advantage, right? Where everything that sits on top of BOSH director does not typically care about the IaaS. So of course, there's few other things that we're not really touching upon today, at least, like load balancers and whatnot. And who knows, maybe in future CPIs do orchestrate some of these other sticking points. All right, so moving on, you know, specifically talking about Kubernetes CPI, you know, what does it do, right? So given that Kubernetes, as I mentioned before, provides lots of different primitives to be kind of a build upon, right? Kubernetes CPI automatically, you know, uses those primitives to achieve, you know, its directives. So for example, you know, create VM call in CPI will create a pod, create disk call in the CPI will create, you know, persistent volume, create VM will also as well create a few other concepts, how those kind of pods should be arranged in a cluster. So effectively, we're kind of trying to hide all of those boring primitives from you with even more boring things on top of it, such that you don't have to worry about all the tiny little details. And of course, given that CPIs are something that the BOSH director just calls itself, and no one else has to know really about them, whatever you deploy on top of BOSH doesn't actually know that it's being deployed on top of Kube. It's just thinking, oh, I'm deployed in some kind of compute environment. It might have been AWS as well. Doesn't really matter. Demo 1. Alrighty. So install Kafka and Zookeeper. I think for the sake of time, we're just going to do one quick thing, which is really install Zookeeper. So I have, hopefully everyone can see this. I have a BOSH already installed on top of Kubernetes on GKE. This is one of the later GKE versions, I believe. As we can see over here, we'll have 3 nodes in this cluster. So pretty tiny cluster. It's been running for some time now, since this is the same cluster that's been used to demo at KubeCon. So what we'll do is we'll take a look at BOSH releases real quick. There's lots of releases here. We'll get into detail why. But the more important one is Zookeeper over here. We also have an existing CF deployment. Close your eyes. We don't have to know about this for now. But there's no Zookeeper deployment already, right? So if we go ahead and, oh, and I guess one thing that we didn't look at is stem cells. So we already have one stem cell over here. It's a Warden stem cell, the same stem cell that people use on BOSH Lights. nothing like exactly the same bits. All right, so let's actually deploy a zookeeper. So I already had a command over here figured out somewhere. The only wrinkle over here, it's not really a wrinkle, but rather something that it's not enabled by default today, is my zookeeper release that I maintain for testing purposes and whatnot doesn't use DNS by default. Eventually it will, but in this particular environment we'll do that, and we'll kick that off. All right, so it will do a little bit of work there. It will start creating a bunch of missing VMs. Now, as I've mentioned before, these VMs are really pods, right? So if we Control-C this real quick and look at Kubernetes inside over here, we'll say get pod, we'll say show labels grep zookeeper. We'll see that about 12 seconds ago or so, we actually requested 5 different pods to be created in Kubernetes. Now, they're labeled in particular ways, and that's how you would find them. But if we reconnect to the BOSH task, let's see what it's doing. All right, so it's almost there. You will note that it's also a little bit slower than a BOSH Lite. Now, the reason why I suspect is because this cluster is a little bit under-provisioned. So it might be choking up a little bit on spinning up some of those things. And maybe the zookeeper processes may also take a little bit longer to start up since it's running already next to a bunch of pods from a different deployment. All right, so the deploy, as you see, is exactly the same procedure. We'll circle back to it. We'll run some smoke test after it, after it's done. But at least in a reference of time, let's see. Let's hop on to the demo one. All right, so install Kafka Zookeeper. Great. What do we see? Well, we saw this step. We'll see this step shortly. We won't see the Kafka stuff, but you're welcome to follow some of the instructions in the repo URL share. What do we see? Well, we had BOSH on Kubernetes. We kicked off some Kafka stuff. Mostly right now we're concerned with the installation step, but of course anything that you typically do with Kafka BOSH release, you can do, for example, query its status, maybe recreate certain nodes, do an update, do a rolling update such that only one individual nodes get killed and whatnot. The persistent disks are involved, though we didn't see them in Kube, but we can also circle back and check them out. And of course, you can manage other software like this as you've been before. All right, so let's jump into the CPI implementation details. So there kind of needs to be a mapping, right, between BOSH concepts and Kubernetes concepts, right? BOSH concepts are super generic, so it was fairly easy to map the two and kind of align the two together. So we have a BOSH stem cell. BOSH stem cells easily translate to registry images. The CPI itself, when it calls upload, or I guess when the CPI is called to upload the stem cell into the into the system, all it's doing is it's just importing a Docker image from the tarball, the Word image themselves, right? So nothing revolutionary there. BOSH compute unit. I just call it compute unit over here for the sake of not necessarily calling it VM, even though I put it in parentheses. As I was saying, BOSH is a generic compute orchestrator, right? So in this particular case, it maps to pod. In other cases, it may map to a physical machine or maybe container or maybe VM or something else. Persistent disk. PV or PVC, I guess. It's, again, one-to-one alignment. There's interesting kind of problems in Kubernetes currently where you kind of have to align some of the availability zones and whatnot if you do Kubernetes kind of manually. However, in BOSH, because we do have a notion of availability zones, the persistent disks fall into proper places automatically. BOSH networking. Kubernetes provides a single overlay network. I guess it really depends on your networking plugin for Kubernetes, but as a default, that's what it is. And then AZ. Kubernetes automatically marks certain nodes from in a particular AZ with a particular label. So you can specify that in your cloud config, and then BOSH will, make sure that when it's creating a pod, it will ask Kube to put it in a particular AZ. What else we have over here? So some interesting tiny details in some of the pod creation logic. are the following. So we have anti-affinity rules that are automatically applied, right? So for example, having your Zookeeper node being Zookeeper 5-node cluster being spread over multiple machines is, you know, very, very nice, right? You don't, even if it's within a single AZ, let's say maybe you're deploying a testing cluster, maybe you're deploying something else, ideally would spread it around. Now, if you're even across multiple AZs and you have, let's say, more than 3 nodes, right? Maybe you have, I don't know, 5 nodes or something like that, right? Or maybe 9 nodes. You still may want to spread it around to individual underlying VMs to reduce risk of failure. Automatically configure AZ associations. That's another freebie, right? As long as you configure AZs in cloud config, then BOSH will take care of the rest of the spreading it around AZs. And then finally, automatically creating pod disruption budgets. So we'll get into a little bit of detail. Why do we do that? And what are the pod disruption budgets? But note, they're created automatically. All right, so what are the challenges? So this section kind of talks about, you know, what kind of problems do we, you know, previously maybe different attempts of creating CPI by different teams run into, and what we observe ourselves and how we solve them. So first one, kind of a easy one to identify. Hey, Kubernetes doesn't really allow you to do static IPs. You know, what can we do about it? Well, based on our timing, we're just able to enable BOSH DNS, you know, in these releases, for example, in Zookeeper, and it just works, right? So right now, the Zookeeper that we're deploying actually does use DNS, BOSH DNS. CF that we'll get to as well uses DNS. Now, there is one kind of asterisk to this thing is we did actually implement manual networking on top of Kubernetes such that it does maintain the static IPs. It is a little bit expensive because what it does, it creates a service per each pod, but it does work. And if, for example, your service does not like DNS for whatever reason, you could technically run it on Kubernetes with static IPs. But you probably don't want to since DNS is great. All right, what is the next challenge that we run into? So maintain workload availability during node upgrades. And when I say node upgrade over here, I actually mean Kubernetes node upgrade, right? So when you're actually upgrading your Kubernetes cluster, maybe from 1.7 to 1.8, how do you deal with some of the disruption? Maybe your node is failing or something like that. How do you quickly bring things up? So a little bit of note on what exactly is happening in node draining, right? So let's say, as an example, right, you want to upgrade from Kube 1.7 to 1.8, right? And you have this cluster of beautiful, let's say, 10 VMs. You want to typically do it one node at a time, right? Because you don't want to just take out your entire cluster and then just create it anew. If you can, good for you. But for production customers, typically, they are a little bit more cautious about just throwing away their clusters since typically they run some kind of workload and maybe it's not easy to move to somewhere else, though if you can move it, move away. So let's, for example, say we're trying to upgrade a single node. Node is running with Kubelet 1.7. Node is marked as non-schedulable at some point. That way it's not going to accept a new workload. Then it's going to get drained for some amount of time, right? So this is similar to how Diego sells drain apps, right? Where they kind of try to move them off to a different place. So in Kubernetes, node draining is really limited to, hey, let me just kill this container. However, this killing of the container is a little bit more complicated, and we'll get to that in a sec. So eventually, all the containers are gone, node is removed, then eventually new node is created, we'll start the new kubelet version, and then everything goes on. Now, in this time, when we're draining the node, right, what we want to happen is we want BOSH, because BOSH is the generic operator over here, to actually bring the pods that the Kubernetes is killing on this particular node. We want to bring them up somewhere else, right? Now, why do we want to do that? So, for example, for software like Zookeeper, right, maybe you have to maintain a certain number of containers running, right? So if you have 5 Zookeeper containers, you want typically 3 of them running, right? If you have 3 of them, you want 2 of them running at a time, right? So this is where the whole pod disruption budgets come in, and that's where we're gonna jump into a solution over here. So pod disruption budget is effectively a constraint that you can put on Kubernetes, right? And it's a primitive that Kubernetes provides in its core. You can say to Kubernetes that, hey, that's not okay to delete this container until containers with a similar label are healthy enough to continue on, right? So for example, the constraint for zookeeper may be simply saying you can only kill one zookeeper at a time. If any other zookeeper is dead already, or maybe not healthy or something like that, you cannot kill another node of zookeeper, right? So this is extremely important when you're draining the nodes, right? Because maybe you have multiple zookeeper instances on the same node. Maybe for whatever reason, you know, there's just different services on that node that cannot be, you know, all killed at once or something like that, right? So the notion of PDBs is important, right? So what we've done is we have the Kubernetes CPI automatically create pod disruption budgets. Now it's fairly naive right now. It's really creating a PDB with a configuration that you cannot kill more than one thing. Of course, it could be configurable, but the idea is that we're kind of slowing down Kubernetes to actually kill off things at a particular rate, such that it doesn't cause the unavailability. If you don't use PDBs, and if you do use Kubernetes directly, I would suggest looking into that, because if you're running any kind of stateful software on it, you should take a look at, you know, configure it. All right, well, I guess I kind of went over this. I forgot that this such slides exist, but this is how you can take a look at PDBs inside the cluster that you have. What else we got here? So improve BOSH directors resurrection strategy for faster pod recreation. So this is important in terms of how to, when you're draining, right, you want to quickly, you know, bring back those pods somewhere else, right? Goal is to improve, of course, how director resurrects. Ideally, it would be in parallel. Currently, it isn't. There is some pending changes to do there. Still work in progress. All right. What about more complex workloads? Well, as a demo too, we have a Foundry installation on top of Foundry application runtime, sitting on top of Kubernetes. Let's hop over real quick to it. We'll see that our zookeeper is done. We also see that our time is over for this presentation, but just for the sake of it over here, we'll say BOSH instances. We'll see that it's going to look at two deployments over here. One of them is CF. Here it is in HA mode, well, except maybe a blob store. And here's the zookeeper. I also have this other example over here. So we have a Foundry app running on it. This is the load balancer ingress IP on Kubernetes. So if you click on this, Max was kind to deploy an example app. Meanwhile, so yeah, so it's running on Kubernetes. Same exact installation instructions, nothing fancy. There is one ops file to enable one of the newer features in Gartner and C to disable swap limiting, but it should work as is. So it doesn't sound like I have time to run the smoke test, but trust me that they do work. I'm not sure if there's anything particular here. This should actually say do not come with swap space. Most of the Kube distros do not come with swap space because Kubernetes has been on a position of we shouldn't be using swap in the cloud environments. Hence, we had to change Garden run C a little bit. But yeah, one nuance here is we're running multiple CF app containers within each pod. It's something that, you know, that's the current design of CF. Maybe it will be adjusted in future, maybe not. We'll see. Here are some upcoming changes. And I'll just jump directly to these resources over here. Here's the main repo. Thank you for listening. If you have any questions, I'll stick around for a few more minutes. And I yield my time.
Nice, thank you, Dimitri. Just the one thing I would tell you guys, we've been trying this for almost 2 months and we haven't had any issues. So what we'd love for you to try is let us know when you break it, what's going on, and then we can see if we can fix it. But generally, it's been working. So we don't have a lot of time. Of course, Dimitri is always on Slack. I'm on Slack too. You can ask some questions. We got more stuff, Ashish. You know, if you put a CFK desktop chip as a different meeting, and then the ones that are mature, we'll bring them on the cab. All right, thank you, everybody. Thanks, DK. Cheers.
Bye-bye.
Thank you so much. Thanks, everyone.
Cheers. Bye.
Bye, man.